Okay, let's see what's going on here. So what's going on my screen. Looks like we lost that first 20 minutes of recording too. Okay. Is it showing again now? Yeah. Okay.
We lost it.
Is it there now?
There it is.
Okay. Not sure what happened there. Well, we'll go from there. I'll scroll back up, so if you're looking at this recording online, you can at least see the problems we worked on and follow the steps that are written out there. Okay, so back to this lovely order of operations problem. We've got the 2 times negative 3 has to be our next step. What is 2 times negative 3? It is negative 6. And then what's next?
Negative 42 divided by negative 3.
Okay, that brings a good question. Is that subtracting 42 divided by a negative 3? Or is it a negative 42 divided by a negative 3? And the answer is...
It's 42.
Well, the answer is yes. It can be done either way. I can treat this as subtracting 42 divided by negative 3. Or I can treat it as a negative 42 divided by negative 3. To do that, to make it a negative 42 divided by negative 3, I have to change this to plus the opposite. So a negative 42 divided by a negative 3 is plus 14. Very good. If I had done it the other way, it would be minus a negative 14, which is the same as plus a positive 14. So, looking through here, there's no more multiplication or division, so our next level is add and subtract. So we're just going to go across this left to right. 5 minus 24 is negative 19. Negative 19 plus a negative 6. Negative 25. Negative 25 plus 14. Negative 11. Negative 11 plus 1 is negative 10. Now, once we have reduced that parentheses to a single number, we don't need the parentheses anymore. However, I rewrite this problem, they're still there. Why are they still there? Yeah, to separate out that negative 10. So it doesn't look like a negative 3 minus 10. Yes. So all the parentheses that are there right now are not enclosing symbols. They're just separating out those negatives. So there's no enclosing symbols. Are there any exponents?
No.
Next level, multiplication or division. There's 2 multiplications. We're going to go left to right. This time I'm going to treat that as subtracting a 3 times a negative 10, just so you can see what happens. Well, that's minus 3 times a negative 10 is a negative 30. So you can see where I ended up there is with a minus a negative 30, which is going to be the same as plus a positive 30. So if we had treated that as a negative 3 times a negative 10, it would be a positive 30 there. It would be the same thing. Now we've got this division, negative. I can do either a negative 27 divided by negative 3, or I can treat it as minus a positive 27 divided by negative 3. I'm going to treat that as minus, what is 27 divided by negative 3? Negative 9. And because it's negative, I once again have to have the parentheses around it. What's next? I'm going to do my addition and subtraction left to right. 8 minus negative 30 is the same as 8 plus 30, which is 38. Again, we have 38 minus a negative 9, and that color sucks. 38 minus a negative 9 becomes, well, 38 plus 9 minus a negative is plus a positive, which is 47. So those negatives, again, could come back to haunt you. Be careful with them. What's that? That was a lot of fun. Well, and that's why I did the erase and replace up here. I mean, I've done problems. I'll do that the whole problem, but I wanted to rewrite it here just to emphasize what happens when you've finished what's inside the parentheses. But yeah, it saves a lot of mistakes by just erasing it and writing it in, as long as you're careful. Otherwise, I catch a lot of people, they just rewrite the problem wrong, and that's where the mistakes are made. That's the biggest reason why there's no time limit on my test. If you have to sit here for 6 hours taking the test, for your sake, I hope you don't, because you'd be totally fried by the end of that time. But if you have to sit here for that long and take the test, I have no problem with it, because I'd rather have you be careful and do it right than get rushed and start taking shortcuts and make mistakes because you do shortcuts.
Are we going to have to get problems like that on our test?
That depends. How much are you going to upset me between now and tomorrow morning? This first test is usually 25 to 30 questions. The first test is usually about 1/3 word problems and 2/3 just problems. As we go through the semester, a lot of times I get more and more word problems as we go, because that's one of the skills we need to build, is being able to pick down a situation, or take apart a situation and pull out the information from it and solve it. And as we talked last week about then making sure what your answer is what's answering the question. Okay, let's take a look at another one. Let's do 6 times negative 7 minus 28 divided by negative 2 over let's see here. Five times 9 minus negative 4 times a negative 8 minus 1. Is that going to work? I should go plus 1. Really want. So looking at this, again, we've got this line across here. What is that line?
We're going to divide it.
Okay. It is, one of its things it's telling us is division. It's called a fraction bar. Exactly, yes. And like I said, it is telling us to divide, but it's also an enclosing symbol. It's telling us that we have to do everything on top first, then everything on bottom. Even if you're doing it on a calculator, I would do it that way, because trying to enter it all at once can cause a lot of mistakes. So I'm going to do the top. I'm going to do it off to the side here. On top there, what do I need to do first?
Multiply the 6 times negative 7.
Okay, 6 times negative 7 is
42.
negative 42. Now what? 28 divided by negative 2. We have negative 14, right? Now you got to be careful. Make sure you actually have to stop and make a conscious effort to decide. Am I going to treat that as a negative 28 divided by a negative 2, or am I going to keep it as minus and then 28 divided by negative 2? I kept it as subtracting or minus and then 28 divided by negative 2. You could have got the positive 14 as an answer, but then it's plus 14. You've already used that negative, that minus. So I am actually going to rewrite this as negative 42. Instead of minus a negative 14, it's going to be plus a positive 14. So I have a negative 42 and a positive 14. They go opposite directions. It is staying on the negative side of 0. And since they're opposite directions, it's the difference in their magnitudes. So it's the difference between 42 and 14, which is 28. So the top of this is a negative 28. So now we go to work on the bottom. What's the first thing we have to do down there? 5 times 9, which is 45. Then what?
Multiply the negative 4 and the negative 8.
Okay, we're going to multiply negative 4 and negative 8. So here I have 45 minus, what's negative 4 times negative 8? 32, and it is a positive 32. Now, again, be very, very careful. Notice this is what I was working with here. That is a positive 32, but there's still a minus in front of it. So it's still minus 32 there, even though the result of that multiplication was positive. Now what? Perfect. We're going to add and subtract left to right. 45 minus 32 is 13. And then 13 plus 1 is 14. So 14 is the bottom. So then what do we get here? Negative 28 divided by 14 is negative 2. Very good. Well, since we're playing with our negatives, let's keep going. We've got negative 5 to the power of 4. And remember, we've discussed what this means here. That power of 4 means there's that many of this number multiplied together. This is what we call an exponent. And an exponent has two parts. The base is the number being acted upon. So the base of this exponent is a negative 5. And there are a lot of cases as we start going through here where we have to look at these and we have to have the same base on our exponent. In fact, we've already looked a little bit at stuff like, x to the third times x to the fifth. And what did we get for a result there? X to the 8th. But what if we had had y to the 7th times z to the 3rd? Yeah, it's just y to the 7th, z to the 3rd. Because there's different bases. In order to do that, combining the powers, and remember, we really are multiplying here, but the effect or the appearance is that we're adding the powers. In order to do that, we have to have the same base on those exponents. The other part of our exponent is this. That's the power. The power tells us how many times we're repeating that number. So this exponent, negative 5 to the power of 4, tells us that there are 4 of those negative 5s. They're being multiplied together to give us 625. Now what I want you to do is I want you to take your calculator right now, if you have it with you, and punch in -5, and then most of you use the caret key that looks like that up arrow key or whatever, and put in the power of 4 and see what it gives you for an answer. How many of you got an answer of -625 out of your calculator? All right, something went a little wrong if you got 0 out of it. What's that? Pi. So then your calculator works the easy way. Positive 625 is the correct answer. -625 is wrong. So why is your calculator trying to tell you that that's -625? Well, we just did some examples of order of operations. Negative, making a number negative, is a multiplication operation. It's multiplied by this symbol here is multiplying that number by -1. Which has a higher level of priority? This power or multiplying by -1? Power does, right? Exponents come before multiplication. So when you enter that in your calculator, you have to do parentheses. Because you can see on my calculator, I can do -5 to the power of 4. It'll tell me -625. Because it's doing the power first. 5 to the power of 4 is 625. And then it's applying the negative, multiplying by the -1. So yes, it must be a -5 in parentheses to the power of 4 to give you the 625, which is the correct answer. If you think about it up here, 5 times 5 is or -5 times -5 is a positive 25. 25 times a -5 would be a -125. And then a negative times a negative is going to be positive. 125 times 5 is 625. So how about -2 to the power of 7? You'd think after all these years I'd learn not to use a power of 7 when I do my examples, so I don't have to write them out. Okay, so we've got -2. We've got 7 -2's being multiplied together there. Has anybody punched it in the calculator and got an answer yet? -128 would be correct. If we're going to do it step by step, -2 times -2 is a positive 4. Positive 4 times -2, -8. -8 times the -2 is a positive 16. Positive 16 times -2 is going to be a negative 32. Negative 32 times -2 is going to be a positive 64. And positive 64 times the -2 is -128. Again, you should use the parentheses on that just to be sure. It's actually not in the parentheses. It's giving you the problem. What you are doing, if you're getting a syntax error, is you're using this button right here for your negative. You're using the subtraction key.
Yeah.
That don't work. You've got a minus key, a negative key down here in parentheses by your equal sign.
Yep.
That's the one you've got to use for the negatives. If you try to use the subtraction key, it's going to say nasty things to you. And technically, when I wrote this up here, I should have put parentheses around the -2 just to write it. So now here I've got -3 to the power of 6. You get 729? Positive 729, right? So as you're looking at these examples we've done so far, 5 to the power of 4, negative 5, I should say, to the power of 4 was a positive 625. Negative 2 to the power of 7 was a negative 129. Negative 3 to the power of 6 was positive. If I... Let's go ahead.
And odd, it's going to be negative, it's an even number, it's going to be a positive.
Okay, let's double check that. Let's do negative 7 to the power of 3. What was said here is if the number we're starting with is negative, of course. If our base is negative, otherwise none of this matters, right? If the base is negative, what was said is if it's an odd power, the result will be negative. If it's an even power, the result will be positive. So negative 7 to the power of 3, that is an odd power. So we would be expecting that to be negative. And if you multiply it out, you get negative 343. So it is a negative. So you are absolutely correct that when you're dealing with an exponent, if the base is negative, so an exponent with a negative base odd power gives you a negative answer. Even power is a positive answer. Now this next little thing I'm going to show you technically really isn't part of the course yet. This comes in one of the later units. But I want to show you because of its connection to what we just said right here. What's that symbol mean? Root. In more particular, square root. So if I put the number 36 in there, what that is asking is what number to the power of 2, in other words, what number squared, that's why it's called a square root, equals 36. Perfect, 6, because 6 times 6 is 36. The square root of 36 is 6 because six squared equals 36. Likewise, the square root of 144 is going to be 12. Again, because 12 squared equals 144. So then what would be the square root of negative 25? The reflex is to say negative 5. But if you try it on your calculator, I'll let you try it along with me. Most of your calculators, your square root is a second function. Notice my square root is above my x squared key there. So what you have to do with this is hit second, and then that x squared key, which has got the square root above it. That puts in the square root symbol. I know those keys are a little small to see from your seats. Then enter negative 25. You've got that x squared over on the left side of your screen, just above your caret key.
Oh, I see it underneath.
So you press the second or shift, and then that x squared key, which is the square root symbol. Then put in the negative 25 and hit enter. What does your calculator tell you? Big error, yes. 5 squared is what? 25. Negative 5 squared is 25. Neither one of them, when I squared them, gave me a negative 25. What can I square to give me a negative 25? Well, squared, a power of 2 is even, right? And what did we say up here about even powers? It's always a positive answer. There is nothing that we can square that'll give us a negative answer. Now I'm going to qualify that. This happens a lot in math. At a lower level, they say, oh, we can't do that. And then you get up to a higher level, oh, here's how. You know, at one point, you were probably told you couldn't do 4 minus 7 because 7 was bigger than 4. Then at some point, they showed you negative numbers, so now we can do it. We can subtract and get negative 3. Now, this is not part of this class, and it's not part of any class you would do at WITC unless you took one of our higher-end electronics classes. Then we'd talk about phasors and some stuff like that. For our purposes, you cannot take the square root of a negative number. So if I asked you to take the square root of a negative 5, there is no solution, no answer. It's a big old error. But if you were to go on to a 4-year degree, to a bachelor's degree, and you had to take a college algebra class, which in a 4-year degree you would have to take either a college algebra class or an intermediate algebra class, which is a step below college algebra. Either way, you would encounter this. In our real numbers, some say no solution in the real numbers. By real numbers, I'm talking about numbers that actually exist in the world. In our real numbers, there is no solution to the square root of negative 25. Well, somewhere along the line, some mathematician got extremely bored Now, people ask me all the time, how did people think of this junk? You've got to remember, it wasn't that long ago that we had no television. So they had a lot of time to just sit around and think. Imagine how much more productive I would be if I didn't have television. I can't. It makes me sad to think about all the stuff I could get done. So imaginary numbers, and what imaginary, again, you don't have to put this in your notes because this isn't part of the class, but what imaginary numbers are is they took the square root of a -1 and defined it to be the letter I. I stands for an imaginary number. So I is defined such that I squared equals -1. Well, the problem is, what is I? Well, there is no number that we can put in there for I, so we're just imagining that it's a number. And then because of that, you can go up and take the square root of of any negative number because of I. Again, I'm just warning you that when I say you cannot take the square root of a negative number, I'm saying in most cases, in the real numbers, you cannot take the square root. But if you get into, like I said, intermediate algebra or college algebra, there are methods for doing it. The only practical applications I know of for the imaginary numbers are in electronics. If you get into capacitive and inductive AC circuits, you have phasors, and you do have imaginary components of those phasors. I'm getting some looks from you like, what the heck are those? Yeah. Yeah, phasor actually describes how the voltage and the current in a component of the circuit lags or leads the source. So if it has a real impedance, the voltage is at or behind the source. If it has an imaginary impedance, the voltage actually leads the source. It's above this. It's ahead of the source. Yeah. Well, like I said, I don't. That's not going to be on the test. But I want you to know, I don't want to lie to you For this class, there is no square root of a negative, but yeah, they are out there. So anyway, there are other roots. We know that symbol is the square root symbol for most of us, but it's actually just like any exponent. It actually is part of the exponents. I can have that there. Now this is not a square root, it is a cubed root or a third root because there's that little 3 there. What that is now asking me, third root of 8, is what number to the power of 3 equals 8. So instead of asking me what number squared, that's way up there. Instead of asking me what number squared equals that, it's asking me what number cubed equals that. That would be 2, because 2 to the power of 3 is 8. 2 times 2 times 2. We will go through how to do those on your calculator in the later unit when we go over those. But that is the other side of exponents. So when we say exponents, we think of that base with a power. Well, this is an exponent where we have a base. This is the base, the number inside here. And instead of a power, that's called an index. And the index of the root is synonymous with the power. It's the counterpart of the power, because you can see that tells us what power we would use to check our answer. So if I tell you that the third root of 125 equals 5, five to the third is 125. If I asked you to find the third root of a negative 125, what would you tell me? Can't do it? Doesn't work? Can't take the root of a negative? Is it a negative 5? Is negative 5 to the third power a negative 125? Say yes. Yeah, it is. Negative 5. Oops, I gotta get rid of my big old error. Negative 5 to the power of 3 is a negative 125. Why was I able to do this and not this? Or not this, I should say. Because this was a square root. Go ahead.
That's square and the other one is odd.
Perfect. That was a square root, which means it involves the power of 2. This is a cubed root or a third root, which means it involves the power of 3, which is odd. And when we have an odd power in our exponent, we can get negative results. So when we're going backwards, we can start out with negative numbers. Now the other consequence of all this is I just told you earlier the square root of 25 is 5, right? That was only half true. Because 5 squared equals 25. But what other number squared equals 25? Negative 5. So when we take a square root, there are always 2 answers. Now again, in the real world, the applications we do in this class, most of the time, we're only concerned about the positive answer. But if we get into some engineering type applications, there will be times where you are concerned about the negative answer. Okay, so let's now get back to working with our order of operations. But this time I'm going to combine one of the things we learned late last week. Rather than just giving you the problem with all the numbers in it, you can get something like this. I can ask you to evaluate D minus C, parentheses, 4a minus p squared plus 17, and close the parentheses, when D equals 7, C equals a negative 2, A equals negative 5, P equals a negative 3. So what I have to do is replace each letter again with the number that is assigned. So for D, what am I going to use? 7. And then minus, instead of C, I'm going to put in negative 2. So notice I'm putting it in parentheses to show that that is a negative 2 for C. Well, now I also have an open parentheses there, so I gotta make sure that's still there. 4a is going to become 4 times the negative 5. Very good. Minus negative 3 squared, negative 3 to the second power. Then notice again I put the negative 3 in parentheses. Plus 17 and close my parentheses. Now I put these 3 parentheses in here for a couple of reasons. Reason number 1 is so that if I'm doing this by hand, I keep it very clear that those are negative numbers. Reason number 2 is if you're going to just enter this all in your calculator, those parentheses will make sure the calculator does it correctly. Now that is one weaknesses of some of your cell phone calculators, by the way. They do the negative powers and stuff correctly without parentheses, but they don't always do the order of operations. Sometimes as you enter the thing, when you hit the next operation, it tries to do the previous stuff. So it doesn't always wait and do your answer all at once and do the order of operations correctly. So you may want to try to enter a problem like this at some point and see if it gives it to you correctly. So now we look at this and we're going to have the parentheses here first. Now remember, these ones that I have in the yellow highlighter, those are not enclosing symbols. Those are just separating the negatives. So the only enclosing symbol here is this set of parentheses right there. What do I have to do first in there? Careful. First of all, let's go through the steps. Are there any other enclosing symbols? No. We do have an exponent. Negative 3 squared, which is positive 9. Remember, anything squared will be positive. So then I rewrite the rest of the problem. So now we're still going to be working inside that parentheses. What's going to happen next? 4 times the negative 5, which is negative 20. And I did put in parentheses around that negative 20. What's next? Yeah, we're still working inside that box. And we are going to add and subtract left and right. So negative 20 minus 9. Negative 29. Next. Negative 29 plus 17 is negative 12. Now again, usually when we get a parentheses down to a single number, we don't need the parentheses anymore. But I left them in there because there's a negative 12. So I'm separating the negative 12. But it is no longer an enclosing symbol. Now be careful here. This next step can be tricky. I catch people with it. What is the next thing that has to be done? Exactly. Since there's parentheses here, we don't need the multiplication symbol in there, but it is multiply. So it is negative 2 times negative 12, which is positive 24.
Positive 24.
So what do I have left here?
7 plus.
Nope, there's still a minus out there. I have not used the minus yet. Remember, this is a negative 2 all on its own. I didn't have to use this minus to make it a negative 2. So even though that's a positive 24, the subtraction is still there. So 7 minus 24 is negative 17. Yeah. Change this. This should be a 15 for A. Nope. It is a, yeah, I do have a P in there, sorry. This should be M equals negative 3. The little hamster's running around in circles and stuff today, I'm sorry. I'm going to let you try that one in your notes quick. See what you get. What's that? That is P times M there as well. Yep. So, we're going to start out with what's on top here. A minus BP. What does that become? 15 minus a negative 8 times 4. I guess I don't need the parentheses around the 4 because it's positive. What do I have to do first there? Multiply the negative 8 times 4, which is negative 32. So now I do have a 15 minus a negative 32, which is 15 plus 32. Minus a negative, remember, becomes plus positive, which is 47. On bottom, PM minus F. What goes in for P? Still 4, right? Yep. Times negative 3 minus 7. What do I do? 4 times negative 3 is negative 12. And then minus 7 is negative 19. So 47 over negative 19. That would give us a decimal. So we have to stop right there. That result is just 47 over negative 19. Now when you have that little foreshadowing to our fractions, that 47 over negative 19 is just fine. Since a positive divided by a negative is a negative, you can just put the negative out front. It could be a negative 47 over 19. Or you could move the negative up with the 47. All of those results are going to be the same. It's 47 divided by 19, and the answer result is negative. So either way you look at it. Okay, we're just a touch early for our break. Well, let's go ahead and do that now. That is all of our new material for Unit 1. So when we come back, we're going to take some time to review for our test tomorrow. As I mentioned, for those of you at the other sites, the test should be available at your site by 8 o'clock. I'll try to be here by 8 or a little bit after, so those of you here in Rice Lake, if you want to start at 8 o'clock, you can. If you need a private room, that's for you to arrange. Make sure you go to the library and sign up for it if you want to. The tests will be in the classroom, so you will have to come to the classroom and get the test and take it to your private room, and then bring it back when you're done. Okay, let's take a break. 10 minutes will put us at about 10:16, and we'll start.